name's Dave Matheson. I'm a professor in material science and engineering. I have a secondary appointment in mechanical and aerospace. And I'm a principal investigator for the Wind Energy Research and Commercialization Center. One of our turbines is here on campus, and we have two other turbines out at an industrial site by the I-90 Route 2 split. And Sarah Taylor, who has been Chief Protocol Officer for this visit, is kind enough to ask me to introduce our guests. A few years ago, I was at a conference in Berlin, Germany, European Offshore Wind Conference, and my mission at that conference was to find out if anyone had ever put wind turbines in fresh water. Now, the issue with freshwater versus saltwater is that when saltwater freezes, the first ice to form is almost pure water, and you reject the salt. If you've ever made popsicles as a kid with Kool-Aid, you know that the sugar and the dye gets rejected, and the first part is just an ice cube, and the last part to freeze, that's where all the good stuff goes. The same thing happens with salt water. The first part to freeze is almost pure water, and you reject all the salt, and the last part to freeze is a brine solution. And this causes sea ice, from a materials point of view, to be rather weak. But freshwater ice doesn't have that problem. Freshwater ice is actually a pretty strong material. And so there are engineering challenges when you want to put structures where you're going to have freshwater ice. So my mission at this conference was to see if anybody had ever done that before. And the Germans want to be, of course, claim that, well, they hadn't actually put it in the lake, but they put it on the shore of the lake, and sometimes the lake floods, so does that count? No, it doesn't count. And folks from the Netherlands, of course, they reclaim a lot of land from the sea, and sometimes it rains a lot, and those fields flood. So did that count? No. And then you get into the complexities of the language, because lake in some languages does not imply fresh water. Think about that one. Lake in English means fresh water, but not necessarily in other languages. So I came home from that conference convinced that no one had ever put wind turbines in fresh water. And here in Cleveland, we've been working on a project for some years now with the idea of putting wind turbines in Lake Erie. But we got beat to the punch on that, because these gentlemen clearly have put wind turbines in freshwater, the first in the world, I believe. And just to give you a little difference between Lake Vanern and Lake Erie, Lake Erie is about 5 times as big. Although it's the smallest of the Great Lakes, and we think it's a small lake, it's actually a really big lake. Average depth, Lake Vanern's about 30 meters, Lake Erie's about 20 meters. So a little bit deeper on average than Lake Erie. And the deepest Lake Erie goes is 64 meters, whereas Lake Vanern goes 106 meters. So that implies it has a very a wide variety in the lake bottom on it. Cleveland's at 42 latitude north, and Karlstad's at 58 latitude north. To give you some reference to that, if Cleveland were in Europe, we'd be just north of Rome. If Lake Vanern was in North America, they'd be up nearly at the top of Hudson Bay. So it gives you a little idea, slightly different weather system, but latitude isn't everything in weather. And so our average temperatures in July in degrees Fahrenheit, if that's okay. Whereas 72 degrees Fahrenheit here in Cleveland, and it's the same in Charleston. But in the winter, we average about 25 degrees Fahrenheit here, and they average about 18. So they have longer winters and colder winters, but just as nice as summers as we have. And it will be interesting to see the differences between our lakes and what we can learn from each other. Our speaker's tour was, for all of our academic friends, was actually an academic. He taught courses on how to do wind farm development, and then in a rather unusual move, now does it for a living rather than teaching. There is hope. Åke was also a teacher, but then as I read your resume, you became a politician and then a businessman. So an interesting combination of politics and academia, and I look forward to your talk. Thank you.
Great sheets.
Okay, thank you.
Thank you very much for introducing.
And we are very happy to be here, get the opportunity to be here. And we want to, first of all, thank Sarah Taylor, who made this possible.
Microphone.
Yes.
Handheld.
Handheld, okay. Shall I start from the start, or shall I just continue? Yeah, I said we are very grateful to Sarah Taylor for arranging this. We were invited to Ann Arbor, but she made us make a detour to Cleveland. We like this city very much. And so now we will, we will introduce ourselves.
What picture do you have here?
Yeah. Right.
Okay. Okay, then I start. And first of all, I have to say I'm not as fluent in English as I could be, so I do my best, and hope you will understand this presentation. My name is Åke Petterson Frykberg. I'm managing director, the CEO for our company, Offshore, and I have initiated and I have been the driving force in the project of Lake Vanern since more than 10 years ago. I have been, like we said in the introduction, a politician, but I was in fact a businessman before I became a politician. In fact, I became a politician because it was so difficult to build wind power in the region. So we were an NGO organization that would like to have wind power in the region. So we said someone of us has to be a politician. It had to be you, Åke. And in fact, I joined the Green Party, and I was elected, and I was one of 4 political leaders in the city for 8 years. And I took the project into the city to make it happen. And some other of my friends, they went to the housing company to start working there, and some at the energy company. And there was a lot of people who would like to make this happen. And that was we call it positive infiltration of the society. Yeah, and when I became this city commissioner, it's the same like vice mayor or mayor, it depends on which party you're in. But when I became that, I got the responsibilities for the energy company. We have a local utility owned by the municipality. So I got chairman of the board 2002 in that company, and also in the hydropower company. So I've been working with energy issues in the municipality for many years, and I'm still the chairman of the Karlstad Energy Company. And I'm still some kind of vice mayor for the city, but more in a representative role. I don't work so many hours like I did before. Okay.
little introduction. So I will just show you some of my text. I've written while I was a teacher. I wrote some textbooks on wind power project development. One is published in English by Wizelius in UK, and the bottom one is published in India by the IT Learning. Yes. It's very big. You can see it's 1.5 kilo. Very heavy book. Very difficult to read, actually. You have to sit at a desk. You can't read it in pen.
You have to tell them about the award for the book.
Yeah, we got an award also for that book for the best wind power publication at the Global Wind Energy Conference in Chennai in 2000 and something, 9, 10, 11. Okay. Okay. So now we go to the topic. We will give first an overview of the wind park Vanern. That's the wind farm that's operating since 2010. And then we will give a short overview of our new project, which is another wind farm for 16 to 20 wind turbines, just a few kilometers south of the first wind farm. And technical descriptions of that, since there are many engineers, we will do that. Then Onward will talk to biologists, so that will be a completely different presentation. This is where Karlstad is. Sweden, you know Sweden, it's not Switzerland, it's Sweden, it's Scandinavia. And this is almost in the middle of Sweden, we say. Middle of the southern half of Sweden. And this is the lake. It's actually the largest lake in the European Union. But compared to the lakes you have here, it's rather still is small. Everything in America is bigger than Europe. So this applies to the lakes as well. But this also means that you have your opportunities to develop wind power in the lakes is 100 times bigger than we have in Sweden, actually. So it's good.
And it's the biggest lake in the European Union.
I said that, yeah. But not in Europe, because Lalaga in Russia is bigger. But this is, I think, a little thing to talk about the advantage and disadvantage of offshore versus land and lake offshore versus sea offshore. So offshore, you always have better winds, you have higher wind speed. You also have a better quality of the wind, you have laminar wind, not much turbulence, so that's an advantage also. And you don't have this impact on neighbors actually. Usually offshore wind farms you seldom see them because there's always some mist and it can be long. And also the earth is round and it's much rounder than you imagine. If you come only, say, 55 kilometers out, you don't see it because of geometrical reasons. But on the other hand, you have higher installation costs. Everything that you do at sea costs much more than to do it on land. So every offshore developer will in fact do as much as possible in the harbor or on land and minimize the time at sea. And this applies also to the operations and maintenance. Because you have to boat and sometimes you can't go out there. So, but then to this more interesting question to compare lake offshore and sea offshore. The advantages are that you have less corrosion. You talked about salt. Salt is very mean to all structures. So without salt, you have a lot of less problems. That's really a big advantage. You have less loads because the wave heights are lower. In Sweden, for example, on the Norwegian coast, the max height of the waves is 12 meters. In Lake Vanern, it's 5 meters. And the max wind speeds are also higher at sea than in a lake, usually. And so this adds up to lower installation costs. The turbines will be cheaper and other things as well. Usually, nowadays in Sweden, Europe, we make also with the distinction between near-shore offshore and far-shore offshore. So our is near-shore lake offshore. And if we go to Lake Vanern, we have these two projects. 10 turbines are operated as the red ones, and the other is the wind farm that we have applied for. And we applied for an area, not for specific turbines at specific sites. Because that's the trick, to find the sites where we actually can build. But now Åke will tell us about Lake Vanern.
Is it okay if I call it Windpark Vanern? It's a Lake Vanern wind farm. First of all, it was a national pilot project. We were supported by the Swedish Energy Agency with about 8% of the total investment. So it was not so very much, but it was in Swedish krona 40 million. It will be $7 million about. So, and the total cost for the project was 540 Swedish million. You have to divide it with 7 to get it in dollar. The reason why we were supported as a pilot project was that we were developing a completely new foundation, a rock adapter foundation that has never been used in offshore, or never been used in offshore wind power. And we also developed the vessels that were needed to make the transportation and the lifts, the major lifts, because the Lake Vanern has limited lockers. They are only 13 meters in wide, so, and about 120 meters long. So that made the project quite difficult. So we got this 8%, and we were very happy for that because it helped us to make it a more profitable project. And this is nothing new, but anyway, I would like to show you the reason why we are building wind power. We believe that we have a climate change and that we can reduce the climate change with more renewables and less oil and coal in the energy systems. And of course, we believe at one point the oil resources will end up, and maybe we should do something else with the oil than burn it. Maybe we can use it for other purpose. And for the third, we would like to be more energy independent. So when you know wind is a free resource and you have it where you live. So we're not so dependent on the Middle East oil. So the wind farm, it consists of 10 wind turbines. It's Finnish wind turbines, 3 megawatt each. And it's quite a big size of a commercial wind turbine in Europe. The biggest you can buy at the time is 5 point, do they have any 5? Yeah, the 4.5 is the Spanish Gamesa, which we are looking for in the next project. But around between 3 and 5 megawatts is difficult to find proved technology. So 3 megawatts, the Wind has sold 90 turbines in Europe. So we have some knowledge about how they would work. We could produce about 90 gigawatt hour a year, 90 million kilowatt hours. And if we compare what the Swedes use for household electricity, you will have about 20,000 households that could have their energy from this wind farm. And to compare, in the city of Karlstad we are 87,000 people, and we have about 40,000 households or something. So this wind farm can do a lot in this city. The hub height is 90 meters, and the rotor diameter is 100 meters on these turbines. and the total weight is 220 tons, but you don't lift it in one. And it has been operating since 2010. Some of them were erected 2009. I think I plan to show you a short video. It's only a 3 minutes video, and I will make some comments. But it will give you a picture of how we worked with this project, because when you think offshore, you always think of very huge equipment, jack up rigs, but we tried to make this project profitable. So we have made a lot to use small-scale technology, which do not cost so much when you can work because of weather condition. And that happens all the time when you build it in offshore environment. You have to stop maybe for a week or 10 days until the wind is low enough to work. So we work with small-scale technology as long as possible until the heavy lift, the major lifts. And it's music from Karlstad, of course. This is the prefabricating of the foundation. It was made in the harbor of the city of Karlstad. You can stop here and show that. We make these forms. This is 2 separate forms, and you can build 3 rings of concrete. The foundation is made of concrete. Just remember this picture when you see it later on. You see this steel tube is ordinary ventilation tubes, about 250 millimeters. They are inside the concrete. And you will see why in the end of this. And you can show this. This is how we work. Very, very cheap barges, an ordinary concrete trucks, small digging equipment, everything that you can find in any place where you have a harbor. Pumping concrete there. Mobile cranes lifting these rings to the barges. This looks like we say in Sweden Wild West, but it works. And this is how we did. When we have put all these rings up, we come up over the water, we build this platform that is on top of it. And on the platform we put things that we need to drill the holes down to the bedrock bottom. So we can stand up there with drilling equipment, the same size you use for small wells. 110 millimeter holes is nothing. You drill a couple of meters a minute. So it's very quick and it's very cheap. So this was moved from this platform was moved around to each foundation. Here they are drilling. And here you can see how it looks like when we have injected with concrete in the bedrock bottom, about 10-15 meters down in the bedrock. We have put these wires, and we have injected concrete in the bottom of the hole, and then we can stretch it down 140 tons each bunch of cables, 16 around, and make this foundation connected to the ground. This is the same picture, but just a short history. You know, it's very calm in this picture, no waves. But that's not how it looks all the time. Once in the autumn, we had about 25 meters per second wind, and we have not drilled the holes yet. It looked like this. We were waiting for drilling, and it was not connected to the bedrock bottom. So the waves threw everything in the lake, machines and the platform and everything, and it even moved this foundation about 40 centimeters. So it's very strong waves if you're not connected to the rock. So It was an insurance question, so it was no problem, but it cost some money for someone. And here we have the same small technology, mobile crane on the barge, lifting this flange, this tower flange, the bottom flange, which is connected with the foundation. And here you see the same, here's the first tower part, and it's the same equipment, tugboat, mobile crane, and a barge. And it costs nothing if you have to stop. I mean, if you work with a full offshore rig, it costs you 500,000 Swedish krona, can be $80,000 a day if you have to stop. So if you can wait for the big equipment, do that. They even built a tower factory in the neighborhood city. And this is interesting. This is how we transported the tower parts and the nacelle. We could have, in one cargo boat, we could have the complete tower and the nacelle for one turbine, and we could go, it's about 40 kilometers from this harbor to the site. And then at the same time, the vessel with the crane started from the city castle and met on the site. It took them about a couple of hours, and then they were there. And they're standing up because it's much easier to lift them when they are standing. Otherwise you will need two cranes. So they're alongside each other, the boats, the ships. And the lifting project is just 1 day, less than a day. You can lift towers and you can lift the nacelle. So it's quite easy to find good weather. The nacelle is 127 tons. It's at 120 here. So it's quite a heavy nacelle. It's like a train. And you always look for good weather conditions. So we had to work here even during nights if there were no wind. And the rotor, it was assembled in one part onshore. You see it here, and then lifted in one lift from a barge. So the whole idea with the project is to minimize the work in the offshore environment, make as much as you can with small scale technology, make as much as you can on land. Yes, very shortly, we made a pre-study during 1999. We looked, investigated about 9 different sites in the northern part of our lake. And in fact, I did a pre-study myself. It was just 2 years before I became a professional politician. So I made this as a businessman, in fact. And we were looking about the good wind conditions, of course, and we were looking to minimize the conflict with the nature interests. So we tried to find a part of the lake that was not already a nature reserve area, and everything that is over the water is in some way impossible to build on. So that's why we were looking for something about under the water, because no one had taken interest of this yet. So we were looking for shallow water between 4 and 15 meters, 4 to 12 meters. And we find quite a few good places to build, and we decided to build in this place because we have a very good grid connection possibility there. There is a pulp and paper factory 7 kilometers north of the wind farm, so it made the cost very low to get it in, get the electricity to the grid. And we started wind measure. We started put a mast on the lighthouse, and we have measured there since 1999. And the average wind speed is about 7.2, 7.5 meters per second in the upper height, 90 meters. At 80 meters is 17.2. And we also have these wind resource maps that were made by the Swedish Meteorological Institute. And it shows the wind energy content on 80 meters height. And this is how many thousand kilowatt hours you can get the energy content in 1 square meter of the swept area, the turbine. So the first project is around here, and the second project is around here. So it was the best wind conditions we could get in this region. And this is only a picture from over the pulp and paper industry, and if you look close, you can see the windmills are halfway up. And we usually argue with the politicians about the renewable energy, how friendly it is to the climate and to the environment, and we always compare with the coal energy, electricity produced by coal. And it's in fact it works that way. In Scandinavia we have a energy market together, Finland, Norway, Sweden and Denmark. And Denmark have a lot of coal production, and we can show that when we put in 1 kilowatt hour made from renewable energy, someone have to take another kilowatt hour out. And the most expensive, and it's crazy beauty here, the most expensive is coal produced energy. But because it's the margin cost. You know, when we talk about wind and hydropower, we don't have so much margin cost. They have mostly capital costs. So the effect is very simple to calculate. So when we produce 90 gigawatt hour electricity with wind power, we will reduce the carbon dioxide with 90,000 tons a year, because there will be less coal burned. And as you can see here, there's a lot of other figures. And we used to compare with cars, because it's an easy way to compare. The environmental impact to reduce the carbon dioxide with 90,000 tons is the same impact if you take away from the streets 31,000 cars driven 150,000 kilometers a year. So that make it visible for the people how much the impact is. And as you can see here, there's a lot of other things that you don't need to take up 36,000 tons of coal every year, and you reduce the sulfur dioxide and further on. Another very important thing in our project was that we would like it to have local ownership. We have the same business idea in Wizelius Offshore now. We try to raise investments in the local region, because we would like the people who live there, who will see the windmills, we would like them to make money on them. So they can count 4 cents, 8 cents, you can it makes it much more easy to build them. So in this case, we divided the 10 turbines. 5 is owned by the municipalities, the 2 municipalities, Karlstad and Hammarö, because we have these energy companies and housing companies in the municipality. So they have 5 turbines, and then a private investor has 3 turbines, and then we have cooperative business. It's making it possible for everyone to have 1 share or 2 shares or 10 shares in the cooperatives. So it's quite interesting that one of them is Kyrkvinden. It's a Swedish church. They have raised money among all the
Parishes.
what?
Parish.
Parish, yeah, the parish church, yeah. So they own one of the turbines, and the other one is owned by anyone in the region and small companies and so on. And we think that this is very important. And finally, it took us 10 years, and 10 years is a very long time. We hope that our next project will be in 6 years, 5 or 6 years, but we're always optimistic. We also have had this pilot money because we made new technical solutions. We bought this vessel from Greece, and we fixed it with the pontoons on each side to make it stable. There is no jack up. It don't work to jack ups to the bottom. So it's a floating, like a big floating barge, and you can have a crane, a normal mobile crane in front of it on the deck, and it's a 600 tons crane that is driven aboard, and you raise the mast on board. So this and the lock limitations was one of the arguments for the Swedish Energy Agency to help us. We made a major lift with this crane, as I already told you, so it's not so much to say about that. It's a 106 meter and 600 tons crane. There are quite a few around in Europe. I don't know what it looks like here. I guess it's the same. We also used, like I told you before, traditional barge for transport, for cable working. So I always have this slide with me because I think it's easy to find out how the principle for this foundation. You can see the bedrock, and this is the concrete rings, the water, and you just drill a hole all this way down to the rock, eject the cables, wires here, and it don't look like this, but this is the principle. And then you tighten them up here. And we call it a multi-pile foundation because, you know, there is a monopile. So word game. And this is one of these rings going out to the barge. You can see here the holes that you saw in the video, the ventilation tubes, they are cut. And it's about 30-40 tons in each ring. And these ones are just built together like a Lego. Do you have Lego here? Good. The Danish one? Yeah, it's very easy to put them on top of each other. It takes just a day. And then you make a concrete surface